trophic levels. The word trophic refers to energy. Each link in a food chain is known as a trophic level. So what they mean by link is like if you go from plant to grasshopper, plant is a link, grasshopper is a link. Each of those is a trophic level. They each have so much energy. Trophic levels represent a feeding step in the transfer of energy and matter in an ecosystem. Okay, biomass, the amount of organic matter comprising a group of organisms in a habitat. Organic matter refers to living things. So biomass is all the living material in a certain community. As you move up the food chain, both available energy and biomass decrease. Energy is transferred upwards, but it diminishes after each transfer. Organisms eat food, but from what they eat, they have to make energy in order to stay alive. Some also get stored in the tissues, and then a lot of it is actually lost as heat. Okay, with trophic levels, we have the food chain, which is a simple model that shows how matter and energy move through an ecosystem. It's like just one segment of a food web. So here is an example. We have algae going to aquatic crustaceans. So that means the crustaceans ate the algae. The crustaceans are going to use that algae and oxygen to make energy. Fish eat the aquatic crustaceans, but the energy is going from the crustaceans to the fish. The fish use the crustaceans plus oxygen to make energy. Raccoons eat the fish. Okay? So the energy is going from the fish to the raccoons. Here's another food chain. We have grass, which is known as the producer. Remember, because they produce oxygen and glucose. The primary consumer would be the grasshopper. The secondary consumer would be the snake. And then the tertiary consumer is considered the hawk. The arrows represent energy flow, not what eats what. So energy goes from the grass to the grasshopper, to the snake, to the hawk. As you go up the food chain, there is less energy available because that particular organism uses what it eats to stay alive. The grass is considered to have 100% energy because it makes its own food, then uses it for energy. So plants don't waste any energy having to get food. So from the grass then to the grasshopper ate the grass. The grass had 100% energy, but the grass had to use some of that for itself to stay alive. The grasshopper is only going to get 10% of what was available. There was 100 available, so the grasshopper only gets 10% of that, which is 10. The snake eats the grasshopper. Now there was 10% energy available to that grasshopper, or for the grasshopper, but the grasshopper used some of that to stay alive. So the snake's only going to get 10% of 10, which is 1. And then the hawk will eat the snake and only get 10% of 1%, which is 0.1%. Okay, food web. Food webs show all possible feeding relationships in a community at every trophic level. It's a network of interconnected food chains. And this next slide is going to show you the difference. A food chain is just one of the paths. The food web are all possible pathways. And as you can see, the arrows go towards where the energy is going, not what is eating what. It's energy flow. It's all about the energy in the ecosystem. At the bottom of the food web are always the producers. Herbivore or primary consumers eat the producers. So the arrows go from the producers to the primary consumers, from the primary consumers to the secondary consumers, from the secondary consumers to the tertiary consumers, and sometimes there's the quaternary consumer. It kind of depends on how you set it up, but quaternary would be the top, which means 4. Tertiary means 3. Okay. We talked about this the other day, but toxins within the food chain. Energy decreases as you go up a food chain or up the food web because there's less energy available because the animal below it used it to stay alive. Toxins, on the other hand, increase in potency as you go up the food chain. If a primary consumer ate the producer and there was toxins in it, it got into the primary consumer. Then the secondary consumer eats the primaries and so forth. So as these animals eat each other, this toxin builds up. And this is called biological magnification. And one of the examples was the DDT and the bald eagles. And it wasn't just eagles, it was falcons, it was eagles, it was hawks. The DDT was building up in them. We use DDT as I think it killed plants, okay, to kill off a lot of plants. It is illegal in the United States to use DDT. It built up in these birds. The birds would lay their eggs would be very, very thin, so when they tried to sit on the eggs or incubate the eggs, they would crush them, and so there weren't any baby bald eagles, peregrine falcons being born. Now their numbers are increasing again since we have eliminated the use of DDT in our environment. Okay, another model that is used besides food chain and food web are ecological pyramid. It's another way to show the trophic levels within the ecosystem. Shows the relative amount of energy or matter contained within each trophic level in a food chain or a food web. Here's an example. Again, you have the producers or the autotrophs. You have the primary consumers, which are all the herbivores, the secondary consumers, and then tertiary consumers. And as I mentioned before, the producers have 100% energy because they are making their own food, and then they can make their own energy. The primary consumers eat the producers, but they only get 10% energy from the producers because the producers had to use that food to stay alive. So if the producers were at 100%, the primary consumers get 10% of that. The small carnivore or maybe even omnivore type animals will eat the herbivores. There was 10% of energy available to the herbivores, but they had to use some of that to stay alive. So these small carnivores or omnivores, it should also say omnivores there, will only get 10% of 10, which is 1%. And then you have the tertiary consumers eating the secondary consumers. The secondary consumers only had 1% of energy available to them, that they had used some of that to stay alive. So again, 10% of 1 is 0.1%. So this is another chart showing that. Plants, the producers are at 100%, the primary consumers 10, the secondary consumers 1. So that's why a pyramid's a nice model to use, because it gets smaller as we get to the top. There's less energy available. So here's just another diagram. Less energy is available to the top consumer. So if you needed energy, you are better off eating the producers. Now some animals don't have that option because they are carnivores. But if we needed energy, let's say we have a cow. Well, the cow ate the producers. The cow would be a primary consumer. The cow got 10%. We ate the cow, we get 10% of 10, which is 1%. Now, if we're a country that doesn't have a lot of food, we don't want to be eating the cows. We would want to be eating the plant type of stuff like rice and grains, which is why we send rice and grain to countries that are in need of food as opposed to sending our cows and pigs. You can feed a lot more people using rice and grain because there's more energy. You can eat less of it but get more energy from it.